Let me reintroduce myself again. My name is Peris Moshiri. I'm a meteorologist working with SWALIM for the longest time. And now just going straight to my presentation. I want just to maybe introduce about the Climate Monitoring Network and just to talk about the journey and say that the Somalia Climate Archive, which is now held within SWALIM, has data backing back to 1894. That's for one station in Kismayo and others 1904 in Mogadishu. And most of the stations were established between 1965 and 1980. Remember what I said, that when SWALIM came in, maybe we can say comfortably in 2005 and 6, we started looking for data from all over the world, and most of the data was even taken from a British Meteorological Office because they had an archive. So that's why we retrieved the data. That's how comes we have these data from all stations. So weather monitoring ceased in 1990, leading to the loss of all the monitoring systems through vandalism and lack of maintenance. Of course, we know what happened in the late 80s and early 90s. So since that time, we didn't have any agency collecting data or climate data in Somalia. Therefore, we have a gap there from 1990 to around 2006 when SWALIM came in collaboration with the Ministry of Agriculture and re-established a number of monitoring stations, and the network has been expanding progressively. So every year we continue to expand our network of the stations, and we are happy the network has really grown. Right now we have over 100 active stations. You will see that in different stations, and I will show you that in the next slide, where I'm saying that we have different types of stations. We have the automatic weather stations that collect different parameters, including rainfall, wind, humidity, temperature, solar radiation. Okay. So that's the automatic weather stations. We have 13 of them. Then we have manual rainfall stations. We have 95 of them. These stations only collect rainfall data on a daily basis. Then we have another type, which is called the synoptic. And the synoptic is also manual, and it's collecting data on rainfall, temperature, and evaporation. We have 9 stations. And then we also have, as part of the hydromet, we have groundwater stations, which are also 9 distributed across the country. And I will show you where they are distributed. And we also have in this list, which is missing here, the river monitoring stations, which are about 9 along the Juba and the Shabelle rivers in the south. So that is just the spatial distribution, or just to show on location on the map on the automatic weather stations. And this is just a picture showing how an automatic weather station looks like. I think we have one at the Hormuud University. You have seen it. Usually we have different types of automatic weather stations depending on the supplier. This one that we have here collects different parameters. Like I mentioned, we have rainfall, temperature, relative humidity, solar radiation, about 8 of them. I can't recall the rest. Yeah. So we have about 13 of them across the country. And you can see that also, like I said again, there's one at the Hormuud University. Not very sure where this one is, but it's either in Hargeisa or Hormuud. I can't recall really the pictures for which station. So this data, of course, it is transmitted via satellite. That's what makes it now automatic, because the satellite picks the data, and then the data is sent to us, and we are collecting this data 4 times a day. Yeah, so, and it is available anytime. So like if you want to check the data for the last 1 hour, you can check. There's a link there. You can go to our systems and check the data, and you'll be able to see the data for the last 1 hour. So we say that this one is almost in real time, but then we say it's near real time because we have the data being transmitted 4 times a day after every 6 hours. So that is the automatic weather station. The other type is let me blow up this. The other type is the manual rainfall stations. This is the most common one. And we have about 95 manual rainfall stations across the country. And of course, the map there on my right shows the distribution of the stations. We have quite a number there. And again, I said, we are partnering with the ministries of agriculture in Somaliland, Puntland, and the FGS, of course, and the member states of the FGS. So we have been doing this since 2006, and we continue to collect data on a daily basis. Now, this one, we have people stationed at every station here, going to the station every day at 9 o'clock in the morning, collecting the data, and then sending the data via a mobile app called Dignin. Of course, you may know that Dignin stands for early warning in Somalia. So they send the data via mobile app, and we are able to receive the data again in near real time. So that is the rainfall stations, 95 stations of them. But of course, if you look at this map, you can see that we are missing out in some areas, like here in the central areas. Of course, even here, this network should be bigger than it is, or we should add more stations. But meanwhile, we just using this and complementing the observed data with the satellite data, which Benard, my colleague, is going to show after my presentation how we get the data, because of course the observed data does not cover the whole country. So that's why we always prefer also to complement the observed data with the satellite data. Then we have the synoptic stations. Again, we have 9 stations of this kind. And just so you may know, there is one in, this is Bura or Hargeisa in Gebile. So in Somaliland, we have that. And you can see that this, if you recall, this we learned in our earlier days in primary school. This is called the Stevenson screen, and this is where we store the thermometers. So in here, we have 4 thermometers. We have the normal thermometer, which is collecting ordinary air temperature. And then we have the wet bulb temperature and a maximum and minimum temperature. So that collects 4 types of temperatures. And then this is the evaporation pan. Of course, we want to know the rate of evaporation on a daily basis. Again, this is done on a daily basis, and there's someone who is stationed at each station to collect the data. And again, also send the data via Dignin app, or record the data and send via email. So we make sure that we get the data, if not daily, at least a week, once a week. Every Monday, we have all this data being consolidated and sent to us so that we are able to follow up and archive the data. So this is a Groud groundwater monitoring station. And here we monitor the water level, the water temperature, conductivity, and salinity. The data is also collected on a daily basis and transmitted via satellite in near real time. So here I was just recommending and saying that we need more stations, especially at this time when we have a drought. We may need to just know what is happening in terms of the water table, just to know whether the boreholes have sufficient water, and so that we can recommend different users, the pastorists, for domestic purposes, and even some people use it for agriculture. So we can just recommend for them that and tell them that there's water here or there's no sufficient water here, because at some point when the water is gets very low, then the quality is also compromised. So when we monitor this, then we are able to tell the users, different users, whether that water is good for whatever use that they need to use. So now coming to an end of my, not really to an end of my presentation, just maybe to highlight to you some of the challenges that we have had with this network. Is data gaps. Like sometimes, we have partnered with NGOs, and at the end of their project, they have to leave. So we discontinue that particular station. So we have those gaps in some stations. We also have gaps, between 1990 and 2006. So it becomes difficult really to do analysis. But then again, here is where now the satellite data comes in, and which is Benard is going to show us. And we are going to appreciate the satellite data because it is more continuous, and it's readily available, and it covers everywhere. So there's a lot of advantage when it comes to the satellite data. Also, another challenge is that logistics do not allow in some places. I mean, it has been difficult really venturing into some places, maybe because of security and related issues. We also have cases of vandalism where we have, like especially the automatic weather stations being vandalized. And another challenge, the last one, is the harsh weather conditions leading to damage of the sensors. Of course, you may realize that these sensors manufactured in Europe or America, and probably they are not put in mind, they do not put in mind the harsh weather conditions in our African setup. So sometimes they come here and get damaged, but the good thing is that we have been able to give a feedback to the manufacturers, and they customize the sensors for us so that we are able to monitor without problems. Just to say, maybe on our needs, we need more stations, as you have seen, and also we need to build more capacity within the government, and also of course create community awareness so that we can avoid things like the vandalism. Maybe this could be a discussion for another day. I was just trying to show that now, after all these years collecting all this data, which is so much and which is really, really good, and it has been quality checked and verified. What we have done beginning of since 2020, we have put all this data together and put it online so that anybody requesting the data can be able to go to SWALIM website and download the data. So this is just showing a platform of online climate monitoring network where you can just go into our website. Maybe later we can share with you, if it is of interest to you, the link where you can go to the site and just be able to visualize a station by station, like, because when you go to the online platform, you can be able to click on a specific station and get to know when maybe it was established and get to see all the data that is there. And above all that, you are even able to download the data from where you are without really coming direct to SWALIM. You just do it online and make use of the data as you wish. So this brings the end to my presentation on just a brief introduction of our hydromet monitoring network in Somalia. Thank you.
Thank you, Peris. Abdirahman, maybe before we move on to presentation by Benard, since you are the host now, if you can make sure you are muting whoever is not presenting. For example, I see Abdi Basir Galaxy is unmuted. So if you can mute so that only the presenter is noise is coming from our speakers. Thank you.
طبعا waxaan ka codsanaynaa in uusan mute u ahayn inuu mute iska saaro codka si dabcan oo wax interruptions xagga codka. Please everybody make it unmute to avoid the noise. Thank you.
Benard, floor is yours.
Benard, we cannot hear you.
We can see your screen, but we cannot hear you.
Am I audible?
Yes,
Hello?
now you're
Okay.
audible.
Yes, now we can
sorry.
hear you well.
Sorry, my microphone was on mute. So I will be taking you through the process of extracting rainfall data. And later on, we'll be doing some simple analysis using a platform called Google Earth Engine. So I'll be covering this session in two parts. So the first one is this session here. I'll be taking you through a brief PowerPoint presentation, just to give you some brief theoretical foundation, so that you get some good context of what we'll cover later on practically. Then after that, we will now go now to the Google Earth Engine, now the practical session. So let's start. This is the agenda. I will explain a term called remote sensing. It is important that you understand it because it's essentially like the umbrella of what we'll be going to do later on using Google Earth Engine. Then I'll cover a bit on theory on Google Earth Engine, which is the core of today's, my presentation today. Now, since Google Earth Engine requires registration before you use the platform, there's a bit where, there's a manual that I'll provide you with after this presentation that will take you through the process of creating a Google Earth Engine account. So I will not take you through that process now because it's a pretty straightforward process. So for you to access Google Earth Engine, you need access to the internet. So I will explain how the interface of Google Earth Engine looks like in a very simple way, in a very quickly way. And then after that, we'll now access the functionality of Google Earth Engine. For you to do this, you must have some knowledge of a programming language called JavaScript. Now, JavaScript is very, very wide. I will not, I don't think I'll cover that, the whole of it today. Yeah, but don't worry, you don't need advanced knowledge of JavaScript for you to be able to understand or to even operate Google Earth Engine. So I'll just, in the manual that I'll provide you, it has explained some very simple and very basic concepts of JavaScript that will give you a very basic foundation that you'll need. Then finally, we'll look at now the rainfall data, and we'll look at how to perform things like extracting the yearly rainfall data per an administrative boundary, like now the Somalia boundary. So there's this concept called remote sensing that I'd like to, take some few minutes to explain. So as you, so we normally have what you call the satellite platforms that normally go around the Earth. As you can see in this image, in this video that is showing on my screen. So these satellites are normally equipped with some special kind of cameras. These cameras are very, very powerful, and they can take images of the Earth. Yeah. So as the Earth is rotating on its own axis, these satellites normally also go around the Earth, taking images of it, as you can see here. Now, we have to understand that it's not only one satellite platform, platform that normally goes around the Earth. The last time I checked, there are about over 4,000 satellites, yeah, going around the Earth. So each satellite normally has its own path, yeah, going around the Earth on its own speed, different speeds, and also at different altitudes, yeah. So so this is an image that I got from the. Kindly mute your mics. Kindly close that. Maliun. So this is an image that I got from the internet, and it just shows a snapshot of the distribution of the satellites that are currently in space. So when the satellites are launched from the surface of the Earth, it's normally done in some kind of a careful and also coordinated manner to ensure that there's no collision with the already existing satellites in the orbit. So a good number of these satellites are normally owned by the government entities. So for example, we have the US. Yeah, for example, we have the US that owns about half of these satellites. Yeah, including the GPS, yeah, that we normally use to determine location using our phones. Yeah, so we are able to do this because there are GPS satellites that are in space, and through some complex math computation, we are able to know our location. So all the satellites normally have different functions. For instance, we have a type of satellite known as the geostationary satellites that fly at a very high altitude of about 35,000 kilometers from the Earth's surface. So in so doing, these satellites normally are able to complete a whole circle within the Earth within a day or even less. Yeah, so they're able to monitor some some weather conditions like the wind and also the cloud formation, and therefore such satellites are normally used to used for purposes like weather monitoring or even weather prediction. So that's why we are able to get information like a cyclone will hit a place in a few days to come. Yeah, it is through such satellite. So satellites normally have different, they're used for different purposes. There's some satellites that are used for, that are used for telecommunication purposes. Some are used for navigation. I've talked about the GPS that are used to give us the locations of places. Yeah, and through the data that we get from these satellites, we are able to do a variety of things. Yeah, a good example of the things that we normally do at SWALIM are the land cover mapping. We are also able to do things like charcoal mapping from these satellite images. We are also able to do things like drought monitoring using some of the data that we get from the satellite images. Yeah, so you can see how valuable these satellites are, and without them, then literally, we'll not be able to do a lot of things, because a lot of activities are hinged on this. On these satellites. So now it's important that we understand this process called remote sensing. Yeah. So it's important for us to understand how these satellites normally collect data. Yeah. So this is what happens. This is a satellite that was going around the Earth. We normally call it the sensor. It is equipped with this powerful camera. Then we have what you call the energy source. This is normally the sun. Then we have what you call the target. The target is normally the surface of the Earth. So the surface of the Earth has different features on it: the bare land, vegetation, water. So we have this energy from the sun. The rays from the sun, the energy from the sun normally hits the surface of the Earth. Yeah. So when it hits the surface of the Earth, from the simple concepts of physics, some of this energy will be absorbed into the Earth. Yeah. Some of it will be scattered all over, and some of it will be reflected. And this energy that will be reflected is what will be recorded by this satellite platform. Yeah. At this point, so different features within the Earth normally reflect this energy differently. For example, we have water. Due to the nature of its surface, it will reflect this energy differently compared to a surface like bare land and also a surface like vegetation. So this energy is what will be recorded by this satellite platform. And data, after it has been recorded, this data needs to be processed further so that we get now the final image that has been corrected due to some errors within the atmosphere. So we have a processing station that is located on the surface of the Earth. And this data is normally sent from this satellite platform to this processing station. So this processing station does some corrections, does some mathematical computations, and then finally gives us a final image that we have gotten from this satellite platform. Yeah. So some of these images are normally free. Some of them you need to pay so that you get access to them. So organizations or the government normally in charge of these satellites normally have some kind of an online platform that users can log in and then either freely access these images or access the images after paying some amount. Yeah. So after these images have been put in some kind of online platform, this is where most of us come in. This point where they at the analysis stage. Yeah, we are the consumers now of these processed satellite images. Yeah. So from these images at a glance, we cannot get a lot of information from them. So we need to perform some kind of analysis in order to make sense of this data. So for instance, we could decide to collect a series of images of maybe covering different areas, or even just covering the same area, but covering different periods of time. And we can use that to monitor, for example, how a forest cover has been changing over time. Yeah. Or we could acquire images in order to map charcoal production in the southern part of Somalia, as I've said, over a period of time. And from that, we could, for instance, quantify how many trees has been cut over that period of time, and therefore make a prediction or even make legislation based on that. Yeah. Or we could even do, collect images, satellite images with some parameters that we normally use to model drought. For example, for us at SWALIM, we normally collect temperature data set that we get from the satellite images. We also collect rainfall data set that I will talk about later on, and also some vegetation conditions. And so we use these to model the drought condition and even predict how the conditions will be as far as 1 month or even 2 months to come. Yeah. So this process that I've just explained is what we call the remote sensing. In simple terms, it's being able to obtain information about something. In this case, information about the surface of the Earth, which you have called the target, without being in physical contact with it. Yeah. So in this case, you're able to obtain satellite images of the Earth, and this is done by this satellite platform that we have called the sensor. Yeah, that is several kilometers away from the surface of the Earth. Yeah. So that's what we call remote sensing. So now I'll talk about what Google Earth Engine is, and where it comes in this, and where it comes in this process of remote sensing. Yeah. So Google Earth Engine is simply an online platform. We also normally use the term cloud-based. Yeah, cloud-based or online platform that normally serves two purposes. Two major purposes. So one is it normally stores this remote sensing data. Once this data has been processed by this processing station, remember I said that it's normally stored in some online platform. So Google Earth Engine is one of these online platforms that stores this satellite data. Yeah. So remember I said that we have over 4,000 satellites up there. So Google Earth Engine normally just stores just a fraction of this data set. Yeah. So apart from providing these data sets, Google Earth Engine also provides a capability of analyzing these data sets so that we're able to gain more insights or even make sense of this data. Yeah, and that's what we're going to do with the rainfall data set. Yes, so let's go to the next slide. So Google Earth Engine is very powerful due to these two reasons that I've said. Storing these data sets, these data sets are very, very big to the level of a petabyte. Yeah, and the good thing about Google Earth Engine is that you don't need to download these images to your computer. Yeah, all the processing is done online using very, very powerful, using very powerful Google servers. Yeah, so everything is done online, and by so doing, we are able to do some very complex analysis within no time. Otherwise, if we have downloaded these images to our computers, I mean, some analysis will really take hours to do. So the good thing also about Google Earth Engine is that we are also able to share our work. I will show you practically how after you have written your JavaScript, you are able to share your work with your colleague. So this is just a snapshot of what is contained in the data catalog. So you can imagine 4,000 new images every day, yeah, being stored in Google Earth Engine. Our concern today, though, will be on this weather and climate dataset. Yeah, but for those who are interested in Google Earth Engine, you can explore some of these other datasets during your free time. As I've said, I've created some small manual that will guide you on this. And I've also provided a link to some extra reading material that will guide you on how you can access these all other datasets. This is also another snapshot of the data catalog. We have also we normally have in GIS we normally have two types of datasets: the raster and the vector data. So the good thing is that Google Earth Engine stores both. So a good example is that it also stores a vector dataset like the building dataset covering the whole of Africa. So at your own free time, you can also using the links that I'll give you later on, you can also explore all these other extra datasets within Google Earth Engine. So as I said earlier on, for you to access Google Earth Engine, you need to have an account. Yeah. So if you visit this link, earthengine.google.com/sign up, it will give you some kind of a form where you enter your details, fill it. It's very straightforward. I've explained it in the manual. So after you filled it, the people within Google will review your application, and within a few minutes or even hours or even days, you'll be granted access. Yeah. So once you have been granted access, for you to access the interface of Google Earth Engine, you simply access, you access the interface of Google Earth Engine through this link here, code.earthengine.com, then you will be able to access the interface of Google Earth Engine. So I will go through that right now. These are some of the extra learning material that that I've given you. I'll also share this presentation at the end so that you get access to this link. So right now, I'd like to go now quickly to the practical session. Let me just minimize this presentation so that I go to the interface. As I've said, you simply write, or on your web browser, you simply, I don't know if my screen is visible, you simply type code.earthengine.google.com. So since I already have an account, yeah, if I click enter, then it will present me with this interface. If you don't have an account, but then if you don't have an account, then you'll not be able to see this interface. So first of all, you must do some registration. So I'd like to spend some few minutes just to explain this interface. Then I'll quickly now go to quickly show you how you can now access the Rainfall dataset. So we have this, I can say 4 major sections within Google Earth Engine. You must have internet access for you to access this platform. So the first section that I would like to explain is this section here. But then each section you can drag it to minimize or maximize each section. You can simply drag it to minimize or maximize. So let me explain this map section here. So this is a section where all our data sets will be shown. Once we do our analysis and run our code, all our analysis will be displayed here. So you can see we are able to switch between the satellite view. If you go to the top right corner, you can see that we have the map and also the satellite. So you can switch between the map and the satellite view. You can interact with this map section by zooming in. You can see the plus button here that you can use to zoom into an area. You can also pan by simply just clicking and dragging your map. You can click and drag your map and pan to your area of interest. So if I'm interested in Somalia, you can zoom out and then drag your map to the area of interest, to your area of interest. Apart from that, you can also draw some shapes. So you remember the images that we'll be dealing with normally cover the whole world. But if you're really only interested in Somalia, then you must clip your data sets to your area of interest, in this case, Somalia. So first of all, you'll be required to draw a shape. So you'll draw a shape to your area of interest so that the data set that you load will be limited only to your area of interest. So in this case, I've drawn a shape around Somalia, and I'll be using this to now clip my data to only this area of interest. You can also delete the shape that you have drawn by simply clicking on this draw shape button here, then click your data, and then click on the delete button on your keyboard. So apart from that map section here, let me just minimize it. We have this main view here. So this is where we'll be writing our JavaScript code. Yeah, this is where we'll be writing our JavaScript code. So once you have written our JavaScript code to extract our data sets and even do some kind of analysis, we will save our JavaScript code. After saving it, it will be saved on this other panel here. So you can see this panel that is to the extreme left. So you can see I have several scripts that I've saved here ever since I started using Google Earth Engine. So once you have written your script, you save it, and then it will be saved here. Once you have saved, then you run your script. You click on run. So once you run on the background, using the Google servers, Google Earth Engine will do some analysis on the backend, and it will display for you your results on this map section here. And if your analysis involves some kind of graphs, then the graphs will not be displayed on the map section. The graphs will be displayed on this section here called the console. Yeah. This panel that is towards the extreme left, you can see there's a tab here called the console. So the console is also used for displaying the errors of our code. Remember, there are some rules of writing your JavaScript code. So if you violate any of those rules, then Google Earth Engine will warn you that there's an error in a particular line of your code. Kindly correct it before we proceed. So the console has two functions: to display the graphs, yeah, the graphs from your analysis, and also display the errors of your JavaScript code. You also have this inspector button here. So this inspector button is normally just used to get values from your raster image. For example, right now, we see that we have the satellite image displayed here. The information that you can get from this satellite image is, for example, the coordinates of a particular point. So if you are interested in getting the coordinates of a particular point, you can maybe zoom in to an area like Mogadishu, zoom into a specific area, and if you click a specific point, then you can see from the inspector, it has given us the coordinates of that particular point that you have clicked. If you click a different point, then you can see that the coordinate has changed. So these are the coordinates of that particular point. If you have loaded a raster image, as you will see later on, we load a raster image for the rainfall data raster image. If we will click any particular point on that raster image, then it will give us the rainfall value of that particular point. So we'll see this later on. So normally, there's this tab here called the tasks. So once we have done our analysis, we might be interested now to export our analysis so that, for example, we do further analysis maybe in our GIS software, or even attach our analysis from Google Earth Engine, for example, to some kind of PowerPoint presentation. Yeah. So to do that, we normally export our data sets. And the exportation is normally done. I mean, it's normally, that process of exportation is normally done from this tab here called the tasks. So we'll see how we can use this task bar to export our data sets. And this exportation is normally first taken to the Google Drive. Then from the Google Drive, we can now download it to our computers. So we'll see all this process practically in a moment. This is also another, this is tab at the top here, this search tab here that we can use to do two main things. One, we can use it to search for places within our map area. For example, we can decide to, for example, if our map was zoomed out, for example, to an area like this, and you wanted to zoom in to Somalia, then you can simply Molif, kindly mute your mic. So for example, we need to, for example, search an area of interest. For example, we want to search Somalia. We'll simply type on this search bar, Somalia, and you can see even before we finish typing, Somalia has already been suggested here. So if you click on this Somalia, then our map automatically will be zoomed in to Somalia. So apart from this bar being used to search places, we can also use this bar to search for data sets. So remember, I told you that Google Earth Engine is a catalog of satellite images, yeah, and also vector data sets. So if you need to search our data sets, we simply put our cursor here, and then you can see that the first option that we have here is Browse Data Catalog. So if you click on that Browse Data Catalog, then a new window will be opened, yeah, as you can see here. So from this window, you can see that we have several kinds of images, yeah, satellite images. We also have climate and weather data set that is of interest for us today. You can see we have the surface temperature data. We have atmospheric data. We also have images. So we normally have the different kinds of images. So this among the 4,000 satellite images that I was telling you about. I mean, the satellite platform that I was telling you about. So Google Earth Engine has, we have this, the most common ones that we normally use in SWALIM are the Landsat, Sentinel, and also the MODIS. Yeah. So depending on the properties of each, for example, if you're doing flood monitoring, we normally prefer to use the Sentinel satellite images because they're normally provided after after 5 to 10 days. So that's good for monitoring a phenomena that normally changes frequently, like for example, the flood extent. Yeah. So at one free time, you can just explore all these data sets, read more information about them. The good thing is that there's some good explanation of each data set. So you can just read each of them at your own free time. So I don't know if there's anything that I've not explained. So at this point, I'll now like to go into showing you how you can use your JavaScript to now extract rainfall dataset. So for the rainfall dataset, we normally use a dataset called the CHAPS. CHAPS is an abbreviation for the Climate Hazard Group Infrared Precipitation with Stations. Let me spell it for you, CHAPS. Yeah, the Climate hazard, infrared, precipitation with station. So this simply rainfall data that combines satellite measured precipitation with also some ground station. Yeah, so there's some mathematical computation computation that they normally do to finally give us a raster data set that shows us the rainfall information or covering the whole world. Yeah. So I don't know if there's anything that I've not explained here. So let me start. Let me briefly take you now through the process of extracting this rainfall data. Remember, I said that we'll be using a programming language called JavaScript. As I told you, you don't need advanced knowledge of JavaScript. You just need the basics of JavaScript for you to be able to do some analysis in Google Earth Engine. So I'll be pasting some JavaScript code here. Then I'll explain to you what what that chunk of code does. Then at your own free time, you just take some time to using the links that I'll provide. You'll just take some time to go through Google Earth Engine in general. So let me just paste something here, then explain what it does. Let me first of all delete this. Let me expand this main section here. So the good thing about Google Earth Engine is that you can also import your external data set. So apart from using the images within Google Earth Engine, yeah, you can also export in case you have images within your computer and you want to employ or even take advantage of the computing power of Google Earth Engine, then you can simply import your image into Google Earth Engine, then do your analysis in Google Earth Engine. So for you to import your data sets, remember I told you have two kinds of data sets in GIS, the vector and also the raster data set. The raster are now the images. So for you to import your external data sets, we normally use this tab here called the assets. Yeah. At the extreme left panel, we have this tab here called the assets. So from these assets is where we normally import our data sets. Our data sets, external data sets. So at this case, I want to now import the Somalia boundary. So I'll be using this boundary now to clip my rainfall data set only to Somalia. Remember I told you that this data set covers the whole world, and I'm not interested. I'm not interested in rainfall data set for the whole world. I only want rainfall data set for Somalia. So first of all, I need to import the boundary of Somalia. So in SWALIM, we normally have this portal called we normally have this portal that you can access it at your own free time, spatial.fawswalim.org. Yeah, so this is an online platform that we have stored all our geospatial data sets. So if after you have accessed it, if you click on layers, you'll be able to see all the data sets that we have in SWALIM. So you can see that currently we have 119 data sets. So out of these 119 data sets, we have, if you click on groups, if you click on this side panel here called groups, you can see that we have, for ease of access, we have grouped our data sets according to some thematic topics. So for example, the boundaries, yeah, if you click on the boundaries, it will automatically filter your layers so that you are only able to see the boundary data sets within Somalia. So I want us to download these Somalia administrative boundaries. You can see that we have the districts, we have the states, but our main interest here is the outer Somalia boundary that we'll use now to clip our rainfall data. So if you click on it, it will take you to another new window where you'll be able to download this this particular data. Let me give it some time. So you can see that it has taken to a new tab. So from this tab, you can see the download layer button. So if you click on the download layer and click on the data menu, you'll see that you can download this layer in different formats. But the format that you are interested in is this geospatial format here called the shapefile. So this is the most common vector format that we normally use for GIS. So if you click on that, then it will download for you that that particular data. So once you download it, I had already downloaded it, so I'll not download it again. So once you download it, you extract it, then you'll see that our vector dataset has these 3 files here. I mean, these four files: SHX, SHP, PRJ, and DBF. So these are the datasets that will be, that will import into our Google Earth engine. So if you come here to your assets, click on new. So you can see that there are different options that you have for importing your data. Remember, I talked about the image, yeah, that you can import in a format called the TIFF. So this is another common format that we normally use for our raster images. There's also this common format that I've just talked about, the shapefiles. So if you click on that, then click on this red button here called the select. Then you browse to the location of your shapefile. Then you simply click on control and select all those 4 files. Then click on open. Then click on upload. So once you do that, it will upload your vector dataset to Google Earth Engine. So I'd already done this, so I'll not do it again. Let me just click on cancel. So all the datasets that you will upload into Google Earth Engine will be displayed on this asset section here. So you can see that ever since I started using Google Earth Engine, these are all the vector datasets that I've uploaded into Google Earth Engine. And one of them is the Somalia outer boundary. So they're normally arranged in some kind of alphabetical order. So let me just scroll down and show you that Somalia outer boundary. So you can see I have the Somalia district. Then here, the one that I have highlighted is the Somalia outer boundary. Yeah. So I need to use it now into my script. So for me to use it into my script, I simply highlight on it. I don't click on it, I highlight on it and then click on this arrow here. This arrow that points to my right. Or even if I click on it, I'll still have the option of importing this particular data into my script. Yeah. So I will click on this import button here. So if you click on import, you will notice that there's a line of code that has been added into your script. And this is the Somalia boundary. So here it is. And at this point, I have the option of renaming it. By default, it's normally given a name of table. Yeah, but I have the option of clicking on it, remove this name, and then give it a suitable name of, for example, Somalia boundary, or even just SOM, yeah, short form. Once I've done that, all through my script, I'll be using this name SOM to clip my rainfall dataset. Yeah. So once I've imported my my boundary into my script, let me just paste some chunk of code, then I'll explain what it does. Just a moment. First of all, okay. So remember, initially I told you that from this search button here, or this search bar here, you are able to browse your data catalog. So remember I said that the rainfall dataset will be using a particular dataset called the CHAPS. The good thing about the CHAPS is that this dataset is available, gives us rainfall dataset from way back to 1981, from 1981 to current. Yeah, so if you want to do some kind of trend analysis to see how the rainfall has been changing over time, then you can simply use this CHAPS dataset. So you can simply type your CHAPS on this search bar here, and it will give you the options. It will give you all the datasets that contains the name CHAPS. So you can see that we have three options here that have already been filtered for us. The one that we are interested in is this charts here. So it provides charts in, it normally provides daily data sets or even printed data sets. Printed is simply a collection of 5 days. Yeah, so after 5 days, they collect that data set and provide for us that particular data set. So I want us, for this case, to import this charts printed data set. Yeah, and for us to do that, we simply click on this import link here, or import button that is towards the end of this particular data set. If you just highlight, then go to the end, then click on import. So it will import for us that image collection into our script. So you can see that now we have two imports. The first import is the Somalia boundary that we'll use to clip our dataset. And the second import is this CHAPS rainfall dataset. Yeah, but this dataset has been provided, I mean, it covers the whole world from 1981. These are very, very huge dataset, but our interest is maybe, for example, only the CHAPS dataset for the year 2021 only, covering only Somalia. So we must further filter this dataset based on our area of interest and also based on the year of interest. Yeah. So what we'll do is what the next thing the next thing that we'll do is what to call filtering our dataset. Yeah. So let me just copy some code here, then I'll explain what it does. First of all, let me rename this dataset. Remember, it has come with some default name called image collection. Yeah, but this let me rename it to some interesting name like CHAPS. Since we are dealing with CHAPS dataset, it will be appropriate for me to rename it to CHAPS. So all through my script, when I need to access this dataset, I'll be calling this particular name CHAPS. Yeah. So let me just copy some code here, then I'll explain what it does. So the next thing that I've done is I've written something here called the year. I'm only interested in rainfall dataset only for a particular year, and this year is 2021. And I want this year, I want it to cover from the 1st of January of 2021 up to the end of that particular year. Yeah. And what I wanted to do, I wanted to give me the annual rainfall data for that particular year. So I'll be using what we call in Google Earth Engine, I'll be summing all those rainfall data set, yeah, of every point, I'll be summing them up, yeah, for the entire Somalia, so that it gives me what we call the annual rainfall data for Somalia for the year 2021, yeah. So I'm using what we call a function. This function is called the sum function. It will sum for me all the pixel information for that raster dataset for all the year and give me a final product, a total annual rainfall for Somalia. And then let me just copy another code here. And then I will visualize this particular rainfall data. Remember, I told you that visualization will be done, or the products of our analysis will be displayed on this map section here up at the bottom. So my rainfall data set, I will want them to be displayed at the bottom here, but I would like it to be displayed using some specific colors. So in programming, we normally have a code for each color. So if you just go to, for example, color red has its own code, blue has its own code, black has its own code. So if you want to see all the codes for all the colors, if you just Google color codes and then click enter, then you will be able to see all the color codes for each color. I mean, all the color for each code. For example, you can see that the color red has this particular code. Yeah. So this is what I have done here. I've specified that kindly when I run my script, kindly visualize for me this rainfall data using these particular colors. Yeah. So we'll see what these colors are just in a moment. And so normally, this rainfall data sets normally range from a minimum of 0 to a maximum of, for example, 2000. I've just used a maximum of 2000, but in some areas, this maximum can even go to about 4000. Yeah, but for Somalia, I've just used a maximum of 2000. You can play around with these figures. Yeah. Then once I've done that, let me just write another code here. Let me paste another code that will now display for me this data in my map area. So finally, what I've done here, this final line of code here, what I'm simply telling my Google Earth Engine is that after you have loaded this CHIPS dataset for the whole world since 1981, kindly filter for me only the year 2021. If you wanted for the year 2020, simply just edit it and write there 2020. Yeah. So once you have filtered for me CHIPS dataset for the year 2020, kindly display for me that dataset using this particular color codes. Yeah. And this rainfall dataset, let it range from a minimum of 0 to 2000 millimeters. Finally, display for me this dataset. And I've done this using this function that we call the map.add layer. It will simply add for me this total rainfall data that I've shown here. It will now display for me this dataset in my map area. So remember what I said initially. After you have written your code, you need to save it. So click on this save button. And then you can see that several folders that I've created. Yeah. Normally it's good. Normally there's some rules of programming. It's normally good to organize your code in some kind of order. And one way that you can use to organize your code is to store related code in the same folder. So as you can see here on my script tab, I have different folders here. Yeah. For example, I have for this training or for this session, I created a folder here called the Somalia training. Yeah. Or even I can simply create a new folder here called for me to create a new folder, I simply click on new repository. Then I can simply write now the name of your university, Hormuud University. And from this, in this folder, I can now save all my scripts that are related to this particular training. So once I've done that, I simply click on create. So once I've clicked on create, those folders are normally arranged in some alphabetical order. So I can simply find it here. You can see H. Yeah. So if I maximize this this folder, you can see that currently it is empty. It doesn't have any script. So I want to save this script in this particular folder. So for me to do that, I simply click on the save button. Then it will give me this pop-up window here. So from this window, from this drop-down arrow, I can now select the folder where I want to save this particular script. So I can now select the folder that I've created, the Hormuud University, click on it, and then give it an appropriate name. Yeah. So for example, I can give it a name, CHIPS rainfall data. It's normally good to give it a name, an appropriate name, so that in case you want to refer or even go back to your script, you will find it easily. So CHIPS rainfall data. Then I click on save. OK. So once you have done that, you can see that now my folder has been populated by this particular script that I've written here, the CHIPS rainfall data. Now the next step is to run my script. Let me run it so that you see how the rainfall data will be displayed on my map area. Click on run. It will take some time to display my data set. First of all, let me remove something here, then I'll explain what it does. Let me click on run again. So you can see it is now displaying the rainfall data covering the, if you just zoom out, you'll now be able to see the rainfall data covering the whole world. Yeah. And these are the color codes that we specified. You can see that it's ranging from color blue to about yellow to blue. Yeah. So the bluish areas are the areas that are receiving high amount of rainfall. If you click on your inspector button, you remember when I started, I talked about the inspector button. If you click on it and click on any point on your map, then you'll be able to get the rainfall amount of that particular point that you have clicked. Let me just zoom into Somalia and click a particular point. Any area in Mogadishu. If I click on any point, I click on it. First of all, you must click on the inspector, then click on the point. Then I'll be able to get the annual rainfall for that particular point that I've clicked. So the point that I've clicked, its annual rainfall is 327 millimeters. That's the total precipitation for that particular point. Yeah. So remember, initially when we started, we loaded the Somalia boundary. As you can see, our rainfall data set is covering the whole world. We don't want to do analysis for the whole world. We only are interested in Somalia. Yeah. So we need to clip our data set using this shapefile that we loaded. So to do that, we normally use a function called the clip. Yeah. So in Google Earth Engine, we have a function here called the clip. Yeah, that you can use now to clip our data set to only Somalia. Yeah. So I've called this function called the clip, and then inside those brackets, I've put the name of my Somalia boundary. So by doing so, now our data set will be clipped to Somalia. Let me just save my script and then run it again. And then you see how different our rainfall data set will be displayed. If I click on run, let me give it some time. You'll see that now our rainfall data set is only clipped. Our rainfall data set is only clipped. Who is that? Who is? Okay, fine. Let me continue. So you can now see that our rainfall data set is only clipped within the boundaries of Somalia. And the good thing, there's something that I didn't talk about initially. There's this thing that we call the layer switcher. Yeah. At the extreme right of your map area, there's this bar here. If you hover over it, it will maximize, and from this you'll be able to switch your layer on and off. Yeah. So you can see if I click it, my layer is switched on and off. Yeah. So from this, you can now see that we have now visualized the rainfall within the Somalia boundary only for the year 2021. And from this, visually you can see that the areas with dark blue are the areas that are receiving high amount of rainfall. For example, you can see that the southern part of Somalia is a bit darkish, dark blue. Yeah, it is based on the color code that you have used. And from that, you can see that it's the area that is receiving high amount of rainfall. And you can confirm that by simply clicking on the inspector tab, then clicking on any. And then clicking on any point that is dark blue. If you click on that point, you can see that the particular point that I've clicked, for example, receives 545 millimeters of rainfall. If I zoom into another area, the northern part that you expect to receive little rainfall, if I click on anywhere that is a bit orange in color, let me just click on this point here, you'll see that compared to the dark blue area, you'll see that now this area is only receiving 84 millimeters of rainfall. Now, another thing that is that could be of interest now to us is, for example, we want to now show the mean annual rainfall for the entire Somalia. Remember that at this particular point, we are only visualizing. We can only obtain the sum or the annual rainfall for points, for particular points that we click. Yeah. For example, if you only want this point, we click on it, then get its its annual rainfall. What if we now wanted the mean annual rainfall for the entire Somalia in general? Yeah, covering the year 2021. In that case, we'll employ, or we'll use a function called a Google Earth Engine function called the mean function. So what this mean function will do, it will pick all these point values that you're clicking currently, all these point values, and get the mean. Yeah, for the entire Somalia, it will pick all those point values and then get a mean value, and then display for us the mean value, the mean rainfall value for the entire Somalia. So let me just paste a chunk of code here, then I'll explain what that does. Just a moment. Let me paste it and explain. Just a moment. So what I've pasted here, this is what I've pasted. Let me just create some space so that you see it correctly, clearly. So what this chunk of code does, as I've said, is it simply picks every pixels within it picks every point within this raster dataset that you have displayed here. It picks it, then it computes the mean value. Yeah, it computes the mean value for only the Somalia boundary. Then I've finally printed, I've used a function called the print. So this print function, it will display for us now the mean rainfall data for the entire Somalia. Then it will display for us that value here. Remember, I said the console, from the console, we can be able to visualize either graphs or text values, and also the errors within our code. Yeah. So let me just run that. Then we see what we'll have. So when we run that, you will see that it has displayed for us a value here, and this value is 233. So this is the mean annual rainfall for Somalia for the year 2021. Yeah, if you wanted the mean annual rainfall for the year, for example, a year like 1987, then you simply remove the 2021, and put there 1987, and then save our script, and then click on run. So you can see that in 1987, the mean annual rainfall was a bit higher. Yeah, it was 319 millimeters. Let's test another one, for example, 2000, so that we see how it has been changing over the years. For the year 2000, for example, it was now, it was 267. So you can see that the mean annual rainfall has been reducing over the years. Yeah, let's try 2010. Click on run. It's 279. Let's try 2015. Click run. It's 320. So it has been fluctuating over the years. Yeah. So the next thing that I want now to show you is how you can export this particular data set. If, for example, you want to do some kind of further analysis with this raster data set, and you want to do some kind of analysis in your GIS software, yeah, then you need to export this raster data set to your Google Drive. Then now export it now from the Google Drive. You export it now to your locally to your computer. So let me just paste some chunk of code here. It's a chunk of code that I normally use to export the raster dataset to the Google Drive, and then I'll explain what it does. Remember, I'll give you a manual. This manual has explained everything in detail, so don't worry. So this is a chunk of code that I've pasted. And what this chunk of code does is that it enables us to, first of all, allows us to specify the raster dataset that you want to export. So the first parameter of this function here that we call the export.image.toDrive is what we call the image. So from this image, this is where we now specify the image that you want to export. Remember, the image that you want to export is this one here, the total rainfall, yeah, clipped to Somalia. And that is what, this is the name that you have specified here, total. Let me just remove this. You have specified the name total. Yeah, this is the total rainfall for the year 2015. Then the next parameter is the description. This will double up as the name of this particular image that you have exported. So let me give it an appropriate name. For this case, we are I've changed the year to 2015. So let me just change this year to 2015. I'll be exporting this image, and I'm giving it a name, 2015 total rainfall. Then I will specify a folder within Google, within my Google Drive, where I want to export my image. And so within your Google Drive, if you go to your Google Drive, drive.google.com, you need to create this particular folder. So this is a folder where this image will be exported to. Yeah, so you need to go to your Google Drive, create new, then new folder, and give it that particular name. Then the region of our region of interest is Somalia. Remember, this is the name that I used initially. This is a name, this is our area of interest. This is a boundary for Somalia. So I need to specify it in this parameter here called the region. Then normally we have what you call the scale or the resolution. This is the resolution of our image is normally 5,000 meters. Then in GIS, we also have what you call the coordinate system. Yeah, this is also another topic, a complete topic that I don't want to talk about now. But we normally use a coordinate reference system called the WGS84. Yeah, so this is the code for that particular coordinate reference system. It's normally 4326. Yeah, so once you have done that, then simply click on save, then run your script. So once you have run your script, remember there's this taskbar that I talked about initially. Once you have run your script, you notice that this taskbar has been highlighted in color orange. That means that there's an active task that needs to be completed. So when you click on that task, you'll see that it will also give us another opportunity to confirm that we want to indeed export this particular image. Yeah. So if you need to click on this run. If you click on this run button here, then it should give you an opportunity to confirm the parameters that you have entered, check whether they are correct. Yeah. Once you're satisfied with them, remember the format of our images is TIFF. Yeah. TIFF is a format that we normally use mostly for our images. So once you have confirmed that, simply click on run. So this will take some time depending on the size of your area of interest. So our area of interest is clipped Somalia. This will take it will take relatively shorter time compared to if you are exporting an image for the entire world. Yeah. So you can always monitor the process of this export from this taskbar here. So our exportation is still active, and you can see that this bar is color gray in color. If the exportation is completed, this bar here will turn to color blue. So you can see I have several tasks here, yeah, that were completed that were completed some time back. Yeah, so you can see that my exportation is complete. You can see that it has turned to color blue. So let me see my my data. I need to go to that particular folder. I don't know if I created it. Let me just Yeah, this is my exported rainfall data. So I can simply now right click on it, then download. So it will now be downloaded to my computer. And once it has been downloaded, I can now open it in my other GIS software that I can use now to create a map from it. For example, if you are aware, we have a GIS software like Qgis or even ArcGIS. Yeah. I think that's it. That's simply a brief overview of how you can use Google Earth Engine now to obtain mean annual rainfall data for a particular area. Yeah, if I was interested in a particular district, then instead of using the Somalia boundary, then I need to now use my assets tab. I need to now upload that particular district to Google Earth Engine, and then use that particular district to now display the mean annual rainfall for that particular district. If I'm not interested in a district, I can simply use these tools within Google Earth Engine and draw a particular area of interest. Yeah, for example, I can draw up a particular square and then use this particular box to now compute the mean annual rainfall only covering this particular bounding box. Yeah. So there are several things that you can do with Google, with Google Earth Engine. This was just a brief overview. I will give you this, my presentation, so that you, that presentation and also a manual that I've created, so that you, at your own free time, go through some of the things that you can do with Google Earth Engine. So I'd like to stop it at this particular point. I don't know if there are any questions, anything that wasn't clear that I need to clarify. You can ask it at this point. Thank you.
Bernard, can you please proceed how to convert from the QGIS?
Okay, fine. So
yeah,
once, So once you have downloaded your data from the drive, you can see that I have it locally in my computer. Here it is here. I can now go to my QGIS that I have displayed on my computer. Then go to now to load data sets in your QGIS. I don't know if you guys are know how to operate QGIS, but if I go to layer, add layer, then add raster layer, I can now browse to the location of that particular raster layer. Let me see where it is stored. Or the easiest way is to simply just click and drag. Click and drop. Drag it and drop it in your QGIS, and then you can see now we have our raster, our rainfall raster dataset. And from this point, you can also do some further styling, just the same way you did in Google Earth Engine. If you right-click on it, right-click on that particular layer, go to Properties. You can play around with the styling. If you go to Symbology, then click on Single, this render type. Click on the pseudo color. I can be able to choose various color options. As you can see here, let me just use the default for the purposes of time. If you click on OK, so you can see that you can also be able to display it in various color schemes. Yeah, just the same way we did in Google Earth Engine. Yes, back to you.
Okay, thank you for that. So we remain someone else to consider.
Benard, perhaps you might want to mention the possibility of extracting those values from the raster to Excel.
Okay. Yeah, let me see. So I can cover that. I mean, I can cover the process that I normally do in QGIS, right, Michael? Using that particular script, eh?
Yeah, it's just a quick one. The quick one to show you the possibility that actually you might not be wanting to map it, but you just want those values. Yeah.
Okay. Fine. So let me just copy something here, then I explain. Just a moment. Just a moment. Let me just copy something, then I'll explain what it does. Just give me some moment. Let me load the districts within Somalia so that I show you how you can now extract the mean rainfall per now administrative boundary, like now per district. Just a moment. Or even let me use states. So let's say that I am interested in, let me just style this for just a moment. So I've loaded the Somalia states. These are the state boundaries. So let's say that I'm interested in now extracting the mean annual rainfall per state, I mean per particular state. Let me just label them, show the labels. So I'll want to obtain one single value for Jubaland, for Banadir. So what I normally do, this is some kind of advanced advanced analysis that I normally perform. I normally use what we call the Python. Python is also another programming language that I normally use. Remember, I talked about JavaScript when I was starting. I also use the Python. So within Python, I normally write a script. So this script, I simply tell my QGIS that go to each pixels within each administrative boundary. Yeah, remember, each raster dataset are normally composed of pixels. If you zoom in further, you will see that there are some square boxes, yeah? And each box has a particular value. So I'm simply telling my QGIS using this script that I've written, I'm simply telling it that go to each administrative boundary, and within each of those pixels, within each of these boxes, compute for me a sum, yeah? And then, I mean, compute for me an average value for an average value per each administrative boundary. So it will go to this administrative boundary, extract for me each of those pixels, and compute for me an average, and then store for me that particular value somewhere. It will go to the next administrative boundary, this other boundary here, extract all those pixels within that boundary, and compute an average annual rainfall for that particular boundary. The same, and so on and so forth, up to it. I mean, up to this particular the last administrative boundary, which is the Somaliland. So once it has done that, it normally stores those values in a particular column, and we'll see that in a moment. So let me just run this script. Just the same way we were running scripts in Google Earth Engine, we can also do the same in our QGIS. So once we have written our script here, we simply click on this run button. Yeah. So there are some things that I need to specify. First of all, before I run my script, let me just put everything in order. Just a moment. Copy, then let me put my image in some folder. Then I need to copy the path of this folder and then specify it in my script so that it will go to this particular folder. And then from this folder, it will extract the image and use the administrative boundary that I've displayed. Just a moment, let me tidy it up. Yeah, so once now I've specified the path of that particular folder, I mean of that particular image that I've loaded. So once I've specified it, I simply click on run. Then on the back end, it will do the computation. Yeah, the average computation that I was talking about. Once it is complete, I can now access this information. If I go to the attribute table of this Somalia states, let me just open it. Right click, then go to open attribute table. I'll be able to see that particular information. It has been added as a column. And this column, this is the final column here. So this is the mean annual rainfall per state. Yeah. If I wanted it, the mean annual rainfall per district, then instead of using the state's boundary, I'll simply remove this and upload the Somalia districts. Yes, so that's a process that, that's a process that I normally follow to get the mean annual rainfall per district. And I can simply export this in a format like CSV. For example, if I right click on this layer, go to export, save feature as, I can now, instead of exporting it as a shapefile, I can now choose a format like CSV, the comma separated value, and then export my, let me just export it so that you see. Let me write it there, the states, some states mean rainfall. Click on save, then okay. So it has been exported. Let me open it in my computer. So here it is, the CSV file. If I double click on it, I'll be able to see. That particular mean rainfall data per state. Yes, so that's it. Any other question?
Yes,
can you show us that rainfall .bing? Yeah, you click it. You want to see the picture, image of that. Rainfall 2, rainfall 1.
I didn't get
yes.
your question.
Yeah, in your folder, we can see that rainfall 1 or rainfall 2. Those image, can you click it? We want to see that.
In my folder?
Yeah, in your folder. That.
Here.
Another page. Yes, this one. Bing. After satellite, yes, this image.
Oh, this one.
Yeah,
oh, so.
Yes.
Oh, so these are just maps.
Yeah.
That
It's Somali maps, right?
Yeah, it's Somalia maps. I got these images online.
Yes.
I'm not the one who
I know that.
this.
No.
Yeah.
So I want to see them, as this symbology and label. It's very clearful about the color. So it's okay. Good.
Yes. So you can always play around with the colors, yeah.
Yes.
So as I said earlier on,
Yeah.
As I said, for example, now in your QGIS, if you simply come to if you right click your raster layer, go to properties,
yes, you can symbolize
yeah, then symbology. Then I said that initially it was single band gray. If you click on single band pseudo color, you'll be able to now play around with these colors. Under color ramp, there's this option here called the color ramp. If you click on this drop down arrow, you can see that there are several color ramps that you can play around with. Just a moment. Yeah, I mean, from this drop down arrow, you can play around with several colors. Yeah, if you wanted to range, I mean, if you want to use greens, you can simply use greens or yellows or reds. Yeah. So I want my color to, to be, for example, range from color red. Let me use red to maybe blue. Let me use a range of red to blue. So I'll simply use blue here. So my color will be ranging from color 1 red to color 2 blue. Then simply click OK. Just a moment. So I can also specify the number of classes that I want. So currently you can see that I have 9 classes. I can simply reduce those classes to maybe 4 only. Yeah, I can reduce those classes to 4. So my color will be ranging from that color red to green, then to blue. So if I click OK, you can see that my color has changed. So you can always play around with these colors. It's not a must that you have this particular color range. Yeah, you can always play around with these particular colors.
Yes.
Benard,
Yeah.
Benard, through Michaela, I think maybe what the colleague from Hormuud is requesting is the process of map production. But I think that one, Michaela, if you agree, we have manuals that we can be able, when Benard is sharing some of the manual for Google Earth Engine, we can also share those manuals for Qgis.
Yes, it was not the scope of this presentation. We prepared the map preparation. So it was more the analysis, the extraction of the data and their analysis. So the QGIS preparation of maps through QGIS is another chapter, is a different presentation. So we can share the material. Abdi, if you want. Yeah, because also it wouldn't fit in the 2 hours limit that window that we had today. So if it's okay for you, we will just share the material, and if you have questions, you can get back to us.
Yes. I think it's fine.
Okay. So I'm sure there was a lot to take in for the students, for the attendees, everyone. A lot of information, especially if you're not familiar with JavaScript, Google Earth Engine, QGIS, and everything, if it's all new to you. But I hope you can manage through the material to repeat what Benard was showing. And these things you only learn by doing, so keep practicing and use the tutorial that you can find online as well. There's a background noise from the host.
Okay, Michaela and the FAO organization, we much appreciate that for your presentation. I think the students and participants more useful about this. So we're heading to close our session. If the participants doesn't have any questions regarding to this presentation, so if someone having any question, please carry on. We're going to conclude our session. يا سؤال طبعا ويدينا انت هذا كنت جرتو سؤال منك طبعا يا ويدين كرا ويلكم متكفرو هذا سؤال قبل واسكحنا.
Okay, so maybe you can, if you have a lot of questions coming in the coming days, maybe you can compile them and send it in one message to us later.
Okay, good, Michael.
Okay.
Yes. And send us every format you have. So now we just use it QGIS software. I think they are very familiar about the ArcGIS, how to convert and how to create the production of the map. But now we are much useful about how to extract and process data from shapes. So our session is going to conclude it here. And thank you so much for the presenter, for the power organization, SWALIM. Thank you so much. Muchly appreciate your presentation, and it was muchly useful. Thank you, Michael, for your organizing, and thank you, the presenter, Peris, and also Benard. Thank you.
Thank you all, and goodbye.
Yes, goodbye.